I heard you've been struggling with logarithmic equations. Don't worry, I got you. I'll walk you through everything you need to know about grade 12 Advanced Functions, Unit 5, Lesson 2, Solving Logarithmic Equations. Let's go over some key concepts to know for this lesson. A logarithm, or a log for short, has a base, b, the number that is raised to an unknown exponent or power to equal an argument, y. The purpose of a log is to find that unknown exponent. So if we write it out, log base b of y is equal to x. This is the logarithmic form. The logarithmic form and the exponential form can be rewritten as one another. Converting between these two forms is going to be very useful in this lesson. Another concept is the one-to-one property. If the log of one argument is equal to the log of another argument, and the logs have the same bases, then we can get rid of the logs and thus the arguments equal to each other. Think of adding, subtracting, multiplying, or dividing both sides by the same number. The equation is still equal without the extra operations. Then we have the log laws, which follow similar rules to the exponent laws that you probably already know. A sum of logarithms with the same base is equivalent to the logarithm of the product of the arguments. A difference of logarithms with the same base is equivalent to the logarithm of the quotient of the arguments. And a logarithm of an argument raised to a power is equivalent to the product of the power and the logarithm. Know these concepts well, and you're well on your way. Now that we've reviewed the key concepts, let's get into what is a logarithmic equation. Well, whenever the variable x is a part of the argument in a log, then you know that you have a logarithmic equation on your hands. Here's 3 simple steps on how to solve it. The first step is to isolate the logarithm if it's not already isolated for you by performing inverse operations as well as using the log laws until the log is alone on one side. If there's only logs on both sides of the equation, then isolate them for each side. This will come in handy later. The second step, after isolating the logarithm, is to get rid of that pesky logarithm and solve for the variable inside. So there are 2 ways you can approach it. 1. If you are left with the equation in logarithmic form, meaning the logarithm is on one side, then you can rewrite the equation in exponential form and isolate for the variable. 2. If both sides of the equation have logs and their bases match, then their arguments are equal to each other. We're calling the one-to-one property. The logs can then be removed and the variable can be isolated. The last step is to check if your answers are inadmissible. What does that mean? Well, it means your answer can't be 0 or negative because the log of a negative or 0 is simply impossible in the real number system. So it's not a solution. That's why it's important to go back and substitute your answers into the equation to check. And that's it. Simple as that. Now that you know the steps, let's apply what we've learned to 2 examples. Example 1. So we've got a pretty intimidating equation to start out with, but the good thing is that all of the like terms, which are the logs, are on one side. So let's start with our 3 steps. So the first step is to simplify and isolate our logs. First, let's distribute the brackets in this log by following grade 5 BEDMAS. At the same time, you can see there is a coefficient with this log, so we're going to turn that into an exponent and calculate it. Okay, then we combine the logs together from left to right. These 2 logs added together equals the log of the product of their arguments. And we can expand this bracket to simplify. The last thing to do is to combine this difference of logs, which becomes the left argument divided by the right argument. And this just so happens to be fully divisible by this value. So now that we have isolated the log on one side, we can move on to step 2. Solving for the variable by using exponential form or one-to-one property. So since this equation only has one log on one side, it means it's in logarithmic form. Therefore, we can write it in exponential form to solve. So log base of Log base 3 of x plus 8 equals 2 is rewritten as base 3 to the power of 2 equals x plus 8. Then we calculate the exponent and isolate for x. And voila, we have our answer. Hooray. The last thing to do is to check our answer. So let's plug in our answer that we just got into our original equation. And after some calculations, both sides are equal, so the solution is valid. Woohoo! All right, let's move on to example 2. Here's our next example with natural logarithms. Ooh, scary. Let's start with our first step. So simplify and isolate logs on both sides. We'll combine the sum of these two logs through the product of their arguments and expand the brackets. This log is already isolated on the right side, so no more work to do here. So on to the next step, which is solving the variable through exponential form or one-to-one property. So as you can see, there are logs on both sides of the equation, and their bases just so happen to match. Thus, the one-to-one property comes in handy here. Then we'll set their arguments equal to each other and say bye-bye to the logs. Then we'll simplify to the best of our ability. Seeing that there's an x squared and an x at the same time, it's certainly going to be a quadratic equation. So let's make the expression equal to 0. Then we'll use our handy-dandy math skills to factor this trinomial. Boom. Yeah. Okay. Oh. And finally, we'll find what values make each of the expressions in the brackets equal 0. And these values will be our answers. Yippee! But don't forget the last step. Step 3, checking our answers. We'll substitute each of our answers into the original equation and have some calculator magic to go along with it. So as you can see, x equals 2 is a valid solution, but x equals -3 is inadmissible because we have a log of a negative number here, which is undefined in the real number system. Also, when we just plugged our answer into the equation, there was already a log of a negative number, so it would have been clear from the start that this would be undefined. So hope you didn't fall for that. So actually, this equation only has one correct answer, x equals 2. Hooray! I hope this was informative for your little brain. If you need any help in the future with logarithmic equations, I got your back. Okay, toodles.